Welcome to the Hays County Master Naturalist Nature Video Shorts. The topic today is water quality testing. The Texas Stream Team trains and coordinates citizen scientists, people like you, to test water quality throughout Texas. Some of our local master naturalists are testing the water in the Wimberley Valley for the Stream Team. Various tests are performed, but today we're going to focus on one of the tests, how we can estimate the stream flow. Be sure to stay to the end of the video to see some intrepid fieldwork, sometimes required by the dedicated citizen scientists. Here's a map of the various Texas testing sites. Here's a close-up of the Wimberley Valley sites. Now, there are some actual flow meters installed in some streams throughout Texas, but in Wimberley, only a few. So in some places, it's nice to have a way to estimate the stream flow. All right, first we're going to have to go over a little bit of geometry refresher. Flow is volume per unit of time. For streams and rivers, cubic feet per second is the standard unit typically used. Now, remember when you had algebra and geometry in grade school, and you went to your mom and complained, "I'm never going to need this when I'm older." And she said, "Oh, yes you will, study hard." Well, she was right. Let's say we have a square 1 foot by 1 foot. That's 1 square foot of area. If we make it a cube, 1 foot wide, then we have 1 cubic foot of volume. Now, let's say we have a rectangular trough with water, say 8 feet wide, with the water 1 foot high. The cross section is 8 times 1 is 8 square feet. And if the flow goes 1 foot in 1 second, then we have 8 cubic feet per second of flow. It's hard to measure how far water flows in 1 second. It's a short time to be out in the stream measuring things. Let's see how fast it takes to flow 10 feet distance. If it flows 10 feet in, say, 5 seconds, 10 feet in 5 seconds is 2 feet in 1 second. The flow would be 8 square foot times 2 feet a second. That would be 16 cubic feet a second. Got it? Now, here's a problem. We humans love straight lines. Problem is, Mother Nature hates straight lines. That may be why we like to go out in nature so much, for some stress relief. There's no straight lines out there. But that makes estimating stream flow not quite as easy as a rectangular trough. So how do we get that cross-sectional area in the real world? Now, some of you say, this is a time for calculus. Well, remember in high school when you were studying calculus and you went back to your mom and said, "Ma, I'm never going to need this in the real world." And she said, "Oh, yes you will. Study hard. It's going to be important." Well, unless she was one of the computer scientists for NASA, she was pulling your leg. We're not going to use calculus. What we'll do is simplify this by taking the depth, say, every 2 feet, and then approximate the stream cross-sectional area. Some of the 2 foot sections will be overestimated, some will be underestimated, but hopefully they'll balance out a little bit and we'll get a reasonable approximation of the stream cross-section. Next, we'll see how long it takes a wiffle ball to travel 10 feet. If it goes, say, 10 feet in 15 seconds, 10 feet in 15 seconds is 0.66 feet in 1 second. So for 16 square foot times 0.66 feet per second is 10.5 cubic feet per second flow. Okay, enough math already. Let's get away from the whiteboard and out into the field. Here's Cypress Creek, just north of Wimberley by Route 12. Master Naturalist Pat is in the stream, measuring the width, the depth every 2 feet, and the time it takes the wiffle ball to go 10 feet. Master Naturalist Sarah is assisting, writing down the data. The video is sped up to save us some time here. Sounds good for Cypress Creek. Now, what happens about a somewhat bigger stream like the Blanco River by 1492? Well, same story. This time Sarah does the stream work, and Pat writes down the data. Okay, Pat cannot exactly hear Sarah right now when she's in the middle of the stream. But lucky for us, we both know that Sarah's 5 foot tall, so we got those measurements, no problem. So with a little bit of field work, getting a little bit wet, we can estimate the stream flow where there's no installed meter.